Hello there, this is Archit Sabani from second year CSE department KMIT. I'm here to present the second milestone of my project, GenAI powered virtual agent IVR services. In the following presentation, we are going to discuss about the main components of the application, how do they communicate, the tech stack used, underlying data structures, workflow of the application, interface that we can expect, working of WebRTC, transcribers, as well as the LLM model. Firstly, the main components of the application are WebRTC, which makes the real-time web communication possible, connecting the peers over the web browser. The transcribers of speech to text and text to speech, which will be feeding the audio stream from the WebRTC to that fine-tuned model, where the fine-tuned model will be answering the queries of the user. And the tech stack, it is a combination of technologies to create the web apps, which will be holding the above mentioned the components to make it a beautiful application. The communication between the components of this application are majorly depending upon the sockets, Express.js and REST APIs. Sockets, we are using Socket IO for the real-time data transfer. In case of WebRTC, there is a need of transferring the ICE candidates and SD protocols of the users, so called as a signaling. For this purpose, we are using the sockets in order to transfer those, whereas we are using the Express.js as a middleware between the audio stream transcribers as well as transcribers and model. REST APIs are also being used between the front end, back end, and AI services. Tech stack, as said earlier, is a combination of technologies to create a web application. Here we are using the MERN stack, where it's a constant of MongoDB, Express, React.js, and Node.js. MongoDB is a NoSQL database management program which all deals with the schemas. Express is used for managing uh, servers and routes, whereas React for creating the interactive user interfaces. Node.js is for the JavaScript runtime environment. Coming to data structures, we will be storing our data in the form of MongoDB objects. Usually, we plan to store the data of customer and the purchase we made. Under the customer data, we will be having the customer ID, customer name, and under the purchase data, we will be having the product ID, purchase date, time, and the mode of payment, etc. Moving forward, the workflow of the application starts when the user goes to the customer care section of the web application and triggers a call button to the customer care service. Now he will be able to speak directly to the virtual agent. And the workflow will be like when the user starts to speak, his voice will be captured as the input and will be transferred from the user end to the backend over the WebRTC. In between, it will be fed to the transcriber speech to text, which will be converting the user's voice into a text format, and the text will be fed to the fine-tuned LLM model. Now, the fine-tuned LLM model is able to answer the queries of the user, and after the processing of the query, it will be generating a response. It will feed it to the text to speech converter. The converted audio file will be put onto the stream of about TC again. Thus, the user can listen to the output generated by the LLM model. Here we can see the expected interface of our web application. We are focusing on the domain e-commerce. So we can see various products and their descriptions on our homepage. And coming to the customer care service, we are providing with a special feature virtual agent so that the user can trigger a call and speak to the virtual agent where he will be provided with the solution on the voice. The main reason for this is to reduce the resolving time and provide the hassle-free round-the-clock services. Under the milestone 1, we have achieved WebRTC connections. Generally, WebRTC is connecting two peers over the web browser. In order to achieve this, we need to transfer the ICE candidates and the session description protocol of one user and make an offer to the second user. We will be using the sockets to transfer these offer from one user side to the other peer, where after the peer receives an offer, He will be accepting that offer by sending back his ICE candidates and description protocol back to the first peer. When the both SDP and ICE candidates of two peers are exchanged successfully, there starts the flow of media transfer. We can transfer the video, audio over the WebRTC seamlessly without any servers after the initialization. The second is STT transcriber. The audio stream which is transferred over the WebRTC is need to be translated or converted into the text format in order to feed to any LLM model. So we are using few STT transcribers. We have Python, JavaScript based libraries to achieve this, and we have used the JavaScript one, WebKit speech recognition, which will be first verifying our browser supporting. If it accepts and satisfies, it will be moving forward, creating an object for recognition, voice recognition. As soon as the flow of audio stream comes in, it will be activated. It is ready to recognize the speech or the audio. It will try to rectify the errors, minimize the errors, maximizing the accuracy, and finally it will be displaying the result over the screen. We will be using this text format and passing it to the LLM model for further processes. The LLM model we are using is Llama 3 instruct model. We are using the process of RAG, retrieval augmented generation, in order to tend the LLM model towards our application. Starting with the process, we will be providing the input document which contains the answers for the queries generally user asks for. The data in the document will be split into the smaller parts called as chunking. The chunk data will be again fed to the embedded model, which will be converting the chunk data into the floating points called as vectors. The converted vectors are stored in the vector database. The point of doing this is not to make it or not to repeat the process again and again. When the user gives any query as an input, it will be also converted into the vector, and now that vector is compared or searched in the vector database we already made. We will be finding the nearest or the closest similar vector and retrieve the chunks of that vector, combine it with the query the user asked, and provide it to the LLM. Thus, the LLM model will make it more appropriate using its pre-trained knowledge and will be giving the output as a response.
This is the speech to text transcriber, which is hosted on the local server again. We have the two options, start recognition and stop recognition. Off now, it is an individual application which will be transcribing our voice into the text. Let's start with this. It is asking to allow the permission to access our microphone. Clicking on allow. It opens the media stream and access our voice. See, it is listening and displaying the text. The latency and the perfection is quite good. Stopping this will stop the flow of media.
Here is the working WebRTC application. As UI presents two user modes, we have the unlocky terms for this, a virtual agent for the admin, and a customer for the user. When the customer wants to make a call to the real-time virtual agent, he needs to be satisfied with few conditions. Primarily, the user should be logged into his account. Secondarily, the virtual agent should be available on the server. And the next one, only user can make the call to the real-time virtual agent, but no virtual agent can initialize any calls to the user. So let's check the working of this. Logging in as a user, it says the user logged in successfully. Now, in order to start the call, we are clicking on the start call button. To make a call, we need the access of our microphone and permitting it. There starts the flow of our media, which is resembled here. But it says admin is not available at the moment. It satisfied the condition. There is no virtual agent or the admin to pick up the call. So what we should do is we should make the admin available on the server. There is some credential process for the admin. It says admin logged in successfully and the media stream for the admin is open. Now let's go back and log in as user. It says login successful again and try starting to call by clicking on the start call button. Yeah, it shows the call is started and the media is flowing. This is the voice chat application and you can end call from the both sides and it is ended. This is all the WebRTC application.
Thank you.